Hi, this is Ashwini and welcome back to the another video of graph data structure. In previous video, we have completed a representation of our graph. तो सबसे पहले हमने क्या समझा था? We have completed a theoretical implementation, like theoretical and as well as practical implementation, जो कि हम कोड से भी समझ चुके हैं कि कैसे करते हैं और हम थ्योरी से भी समझ चुके हैं कि कैसे रिप्रेजेंटेशन होती है, right? Now, what is our next topic is? Today's topic is traversing of graph. अगर हम बात करें कि क्वेश्चन सॉल्व करने की, तो सबसे पहले एक लैंग्वेज में या किसी एक डेटा स्ट्रक्चर में द मोस्ट इंपोर्टेंट थिंग इज टू ट्रैवर्सिंग दैट थिंग, राइट? अगर कोई डेटा स्ट्रक्चर है तो उसको ट्रैवर्स कैसे करोगे? हर एक क्वेश्चन में सबसे मोस्ट इंपोर्टेंट पार्ट होता है लूप. तो ट्रैवर्सिंग का मतलब लूपिंग ही होता है, ठीक है. अब पर हमारे तरीके अलग अलग हो जाते हैं, हम चीज़ों को कैसे ट्रैवर्स करते हैं. जैसे अगर लिस्ट की बात करो तो लिस्ट में तुम बहुत सारे तरीके होते हैं, वाइल लगाओगे, फॉर ईच लगाओगे, फॉर लूप लगाओगे, राइट? ऐसे ही ग्राफ डेटा स्ट्रक्चर की बात है कि हम इसको कैसे ट्रैवर्स करेंगे, कैसे हम इसकी आइडियोलॉजी समझेंगे कि कैसे करते हैं चीज़ों को, राइट? नाउ तो टुडेस टॉपिक इज ग्राफ. तो हम खत्म करेंगे डीएफएस एंड बीएफएस. आफ्टर दैट तुम्हें किसी पर्टिकुलर क्वेश्चंस फॉलो करने हैं, बिकॉज व्हाट वी हैव डिस्कस्ड बिफोर स्टार्टिंग दिस सीरीज, like after completing the series, what we will do, we will solve some particular questions on graph because we want to make our concept strong on one particular data structure. That's why we have started the series from back, right? तो अगर तुम्हें किसी की सीरीज फॉलो करनी है, लाइक स्ट्राइबर, ग्लबर, जिसकी भी हो, कोई पर्टिकुलर क्वेश्चन हो, यू कैन लेट मी नो इन अ कमेंट सेक्शन. आई विल पिक देम एंड उसको हम सॉल्व करेंगे, ठीक है? सो विदाउट वेस्ट टाइम लेट मी स्टार्ट दिस वीडियो. अब हम बात करते हैं डीएफएस एंड बीएफएस की, जो कि है एक ग्राफ की टू ट्रैवर्सिंग एल्गोरिथम्स, राइट? अगर इसकी बात करते हैं, इसका क्या है ब्रेथ फर्स्ट सर्च एंड इसका क्या है डेप्थ फर्स्ट सर्च, ठीक है? अब ये कैसे काम करती है, अगर अगर नहीं सुना है इसके बारे में, कोई टेंशन लेने की वाली बात नहीं है. जस्ट अलाउ मी अ 5 मिनट, मैं तुम्हें ईच एंड एवरी पॉइंट आई विल मेक यू अंडरस्टैंड, ओके? अब ड्यूरिंग एग्जीक्यूशन एल्गो ईच नोड विल बी ऑन 3 स्टेट. देखो, what this is very important point when we will discuss our algorithm, then you will get to know why I'm saying and why I have put these 3 points here, okay? Now सबसे पहले हम अपने इन 3 points की बात करते हैं, like, and right now just read it about it and I make you understand after 5 minutes when we discuss the algorithm, okay? During execution of this algo, the nodes यानी कि जो vertex की हम बात कर रहे हैं, will be on of 3 states. कैसे? एक ready state में रहती है, एक waiting state में रहती है, and another one be in a proceeding state, or we say processed state, okay? Process state में ready में वो ready है, waiting में wait कर रहे हैं, and processed यानी कि वो process हो चुकी है. ready का मतलब कि हाँ ठीक है, अब processed को हम बोलते हैं visited भी हो चुकी है, ठीक है? So now what thing is, let me make you understand first BFS algorithm. What it is a traversing algorithm of graph data structure. It start from some arbitrary node, okay? Why I'm saying here arbitrary node, like if someone give you the graph like this, so just consider vertexes, okay? Do not confuse. Now अगर कोई तुमको ऐसे ग्राफ देता है, so it doesn't mean like अगर वो बोलेगा कि अगर तुम यहाँ से स्टार्ट कर रहे हो और यहाँ से स्टार्ट कर रहे हो from this one, you can start your DFS from any node, right? It is not any restrictions नहीं है यहाँ पे कि तुम्हें कहाँ से स्टार्ट करना है, कहाँ से नहीं. If someone give you the indexes of this node, you can put a DFS on it, like BFS on it, and if someone give you the node address this one, you can start a BFS from here, okay? Because it is working on a level. So let me make you understand, okay? So this thing we will discuss when we will implement our algorithm, okay? So leave it for the 1 minute. First understand how the algorithm will work. So for making you understand, let me take you to the one note. Let's suppose we are having a graph, and what type of graphs we are having, like one node, two nodes. So I'm changing a graph here, okay? Because from last 2-3 videos we are using the same graph, so you might be thinking, Ashwini, why we are using this, right? Again this one. Now this is connecting to it, and this here, okay? And this is connecting it here, okay? And let me make it more complex, okay? Right? Okay, or do one thing, let me remove this middle one, okay? Now it's look good. Now what you will do, like we will put a value here, A, B, C, D, E, F, G. Okay, so A, B, C, D, E, F, G. Okay, I make a numbering wrong here. So let me erase that one. Okay, so what we will do, yeah, do not worry about it. Let me draw it again. So A, B, C, D, E, F, G, because I just wanted to think in a pattern. So what the BFS says, we marked it here level 0, level 1 and level 3. Okay, so it consider all the things here in a level. Okay, so this is a level 1 and level 2 and level 3. So one thumb rule in a BFS, that it will cover all the nodes. If you are starting from this, it will cover all the nodes on a level 0 before moving to the level 1. So what I am trying to make you understand, let's suppose you are starting your traversing from A. Okay, so first it will go from A to B. Okay, and from B, where it is goes, from B, because now it's level 1 is your completed. From level 1 here C, because why I'm saying it is C, because A, because of A, because C is a neighbor of A, because it's the adjacent of A. Okay, now when you come to C, your level 1 already completed. Now it's turned to the level 2. Okay, and in level 2 it is a neighbor of C, is a neighbor of A, and D is a neighbor of B, and G is a neighbor of B. So this one is completed like this. Okay, and from here it will come to it, and from here it will go here. Okay, so this is just graph implementation of it. If I want to make you understand how your this thing will work. Okay, let me take a one queue here. Okay, so just allow me 2 minutes. I will take a queue here. Okay, so what I have done here, the algorithm which I shows you here, right here, I copied this algorithm for you and I put into the OneNote to make you understand this one, right? And this is your graph which is we have drawn, and see how we can traverse it from level by level. Okay, and here I draw a queue. So what it is your queue. Okay, now check how we do that. Let's suppose we are starting our traversing from A. So now read the algorithm. NQ any starting node vertex. So I just put my A. Okay, and while q is not empty, p dot dq. A p dot, when you say p dot dq, you just take out your A and say if p is unvisited, mark it visited, and give all the adjacent visited like your unvisited vertex of p. So let me mark it as visited. Okay, and put all the vertex of it, like from connection B, right? I will put B and C. Okay, now, and this is your, we can say, output or something. Okay, now we do this again. We go to like p.dq and say if p is unvisited, mark it at visit and save visited, like all the save all the your unvisited like vertex of p into the queue. So as term into the B, so we will mark it as, first we will put a B outside it like NQ. Okay, B, and now mark it at visited. Okay, I'm explaining the whole algorithm. Okay, it will take time like 5 to 6 minutes for explaining it, but after watching this you have the clear picture in your mind. Okay, so let me not change the color, do it faster way. So when you go to the B, and what is the adjacent of your B, like A, it's already in a queue, so we will not put it again. Okay, and it visited, so B and D and G. So what we will do, first we will go to the D and G. Okay, now again go to the C, mark it at visited, and take out it outside, and in terms of C, D already available, and E, right? You say E. Okay, and what we will do now, go to the D because it's inside a queue, right? We are going step by step. D, so mark it, take it out, mark it at visited, right? And what is a neighbors of it? F, right? Now we go to G. Okay, take it out, mark it at visited, and what is the neighbors? B or F is already available, B, right, in a queue. So we go to E, so E, take it out, mark it at visited, right? And now F is already, because if you talk about it neighbors or adjacent, we already available in the queue. So if we now go to the F and take it out and mark it. Now Q is already empty, so from where we have to Q execute our loop in a queue while Q is not empty. In this algorithm you can read it, right? While Q, this line, while Q is not empty. Okay, I hope you understand, like this is your output. Okay, now A, B, C, D. So A, like here, if I traverse from here, A, B, C, D, now G, E, F. So we are going to level, this level to level, level 0, again this level 1, and this is level 2, right? So first in BFS you are going level by level, so that's why I said zigzag in my terms. ये मेरा तरीका है याद रखने का. Like when I was in a college or I doing my graduation, I was just remembering this algorithm by the zigzag algorithm. Okay, nothing. You can create your own idea how you will remember this. Okay, तुम कैसे याद रखते हो, तो वो तुम अपना रिमेंबर करने के लिए एक आइडिया क्रिएट कर सकते हो. Okay, so I hope you understand this theoretical and algorithm explanation. If you understand this, please hit the like button and subscribe. I will see you on next video इसकी practical implementation के साथ. Okay, till then take care, bye bye.